Hello and welcome back. And today we're going to be diving into one of the most useful tools in discrete math and combinatorics, the inclusion-exclusion principle. So we have the question of in a group of 15 pizza experts, 10 like bacon, 7 like anchovies, and 6 like both. We're going to start off with finding how many people like at least one of these toppings. So the formula that we're going to need is because we're looking for at least one. So we need to look the union between our bacon, which we'll call B, or the anchovies. So this formula is equal to the amount of people that like bacon plus the amount of people that like anchovies minus the intersection of the two. So for our question, our intersection, which is going to be our B or A, is equal to just the number of people that like bacon, which is our 10, plus the amount of people that like anchovies, which is 7 here, minus the people that like both, which is 6, which gives us 11, meaning that 11 people like at least one of the two toppings. Now for part B, we have how many like bacon but not anchovies. So we're going to have B but not A. So this is going to be the magnitude of B, which is how many people like bacon, minus the amount of people that like both bacon and anchovies. So for our question here, we have 10 people that like bacon, so we'll take our 10 minus the amount of people that like both, which is 6, giving us our final answer of 4, which means that we have 4 people that like bacon but not anchovies. So now we have how many like exactly one of the two toppings, which means that we're looking for two things: people that like bacon only and people that like anchovies only. And if you remember from last question, we already know the amount of people that like bacon only. So now we just need to compute anchovies only, which is going to be our A but not B, which equals to, again, our magnitude of A minus the intersection of bacon and anchovies. So this is going to give us 7 minus 6, which is going to be equal to 1. But now this is for anchovies only. And since we need exactly one of the two toppings, we still need to add it with bacon only. So from last question, we know that bacon only was 4. So adding it together gets us 4 plus 1, which equals to 5. So therefore, 5 people like exactly one topping. So now our final part is how many like neither topping. So our total group is equal to 15 people. And from part A, we know that people who like at least one is 11. So people who like at least one is equal to 11. So the way to find neither is by doing our total group minus the amount of people that like at least one, which gives us 4, meaning that we have 4 people who don't like either topping. So now we have question 2, which is among 30 math students, 15 know how to program in Java, 12 know how to program in HTML, and 5 know both. How many know at least one of Java or HTML? So again, this is where we're going to use inclusion exclusion. So if we have J for Java or H for HTML, this means that we have at least one of the two, because it's this or that. So this is going to give us the total people for Java plus the total people for HTML, but we have to subtract the people that are counted twice. So for this question, we get 15, because there's 15 know how to program in Java, plus the 12 people that know how to program in HTML, minus the 5 that are in both, giving us 22 students that know at least one of the two. So now for part B, we have how many students know only Java. So just like the last question, we have J, but not H. So in order to do this, we have the amount of people that know Java, but we have to subtract the amount of people that know both, because we're looking for people that only know Java. So this is going to give us our 15 minus our intersection, which is 5, which gives us 10 people that only know Java. And now finally, we have how many students know neither Java nor HTML. So again, we're going to have our total, which for this case is 30. And then from part A, we need the amount of people that know at least one, which is 22. So again, neither is going to be equal to our total minus the amount of people that know at least one, which is our 22, giving us 8. And this is 8 students who don't know either language. And that is how you use the inclusion-exclusion principle. If you'd like more types of questions, let me know in the comments below, and see you in the next one.